Now there is a second formula that you can use for variance when you're working with probability distributions. I don't need you to be able to prove how the first formula is turned into the second formula, so I don't want you to write any of this down. It's enough for you to know that there are two formulas, practice using both, and you're going to get a feel for which one is better in different situations. We also need to be able to recognise each one on our reference sheet. So even though this one says we're going to take each score, subtract the mean, square that, multiply it by its probability, do the same to all of them and then add them up. On the reference sheet it just says find the expected value of x minus mu squared. So you have to know that finding the expected value of something means you're going to multiply those things by their probabilities and add them up. That's what expected value of something sort of means. Now this second formula is mostly easier to use, so I actually really encourage learning this one, and it's actually written, there's one way I write how to do it, and the other way is how it appears on the reference sheet, which is quite confusing. Anyway, back to our first formula. How do we turn it into the second formula? Well, if you just follow along with me here, we've got our first formula, we've got some stuff squared. So to me it makes sense that we should be able to just expand these brackets here using our FOIL method and come up with our first term, our middle term, our last term, and all of that is still multiplied by the probability. On the next line I've said, well, okay, if we're doing all of these things multiplied by the probability, I can expand these brackets and do x squared multiplied by the probability, this term multiplied by that, and the last term multiplied by that. Pretty straightforward. On the next line I've said, hey, if I'm taking the sum of all of this stuff, there should really be brackets around that whole thing, then surely it's the same as taking the sum of this and then subtracting the sum of all of that and then adding the sum of all of that. So here I've just taken the sum of each part separately. Alright, now when you're taking the sum of something, if I'm adding up a whole lot of things and they've all been multiplied by the same thing, let's say I'm doing 4 1s plus 4 2s plus 4 3s plus 4 4s, can't I just do 4 lots of 1 plus 2 plus 3 plus 4? Yeah, so anytime you see this sum thing and something that's in there is a constant, you can actually bring the constant out the front and then just take the sum of all of the other bits. So that's what I've done here. From this line to this line, I've said, hang on, 2 lots of mu. That's just going to be a number. Let's bring that out the front of the sum. Why have I done that? Well, you'll see in a minute. And I've done the same thing here. Mu squared, that's just a number. I'm going to bring that out the front of the sum and then just take the sum of p of x. Now, when I look at this line, there's a few things that jump out. The sum of each score multiplied by its probability, that should look really familiar. That equals mu, or the mean, or the expected value. They're all the same thing. So this bit here, I could replace that whole thing just by mu. And so then I've got 2 mu times another mu. I'm going to get 2 mu squared for that middle term. And it's actually not the sum of anything. The sum's gone now. I've added up all of those things. I get mu. So there's no sum signal required. I've already taken the sum. And this second part, the sum of all the probabilities, well, all the probabilities add up to 1, don't they? I've written that here. So really I've got mu squared times 1. So I'm just going to write plus mu squared. Now if I've got minus 2 mu squared plus another mu squared, that adds up to minus mu squared. So I've still got this complicated part at the beginning where I need to take the sum and then I need to just subtract mu squared. Now this is the second formula. It's a lot easier to use when the mean is an awkward number. So that last method that we used, the first formula, required us to subtract the mean from every single score. Now that's okay if the mean's something nice like 2 and all the scores are nice whole numbers as well. But what if the mean is 3.615 and now you've got to subtract that from every score and you'd end up with just a lot of numbers to write down and a really complicated bunch of working to do. Well, this can be a lot easier because you only have to deal with the mean at the very end, just square it and take it away from all of this. You square each score, you multiply each squared score by the probability, add them together, that'll give you a number, and that gives you all of this part. Then you subtract mu squared. So we call this the second formula, and it's written on your formula sheet like this. It says find the expected value of x squared. Well, just as the first formula said, find the expected value of this, we know that what that means is find these, multiply by the probabilities, add them up. Same thing here, find x squared, all of them, multiply by their probabilities, add them up, then subtract mu squared.